Hello everyone and welcome to Unacademy classes. My name is Abhishek Mishra and in this class we will discuss about thermodynamics subject. We will do our revision. So before starting this class, let me check first of all. Let me open up the chat here so that I can answer your questions and interact with you as the class go on. And let me also see if the stream is working fine or not. It seems everything is fine and we are good to go. So let's start the class. So once again, hello to everybody. My name is Abhishek Mishra and in this class, we will going to talk about the thermodynamics topic heat mainly, and we will going to do in this class some questions mainly from the heat topic and also from the topics that we have covered already like work. And to start this class, let's do some questions from the topics that we have already revised so that we are in touch with that. And there are some nice questions that I think is very important for your revisions that I am just going to do it right now. So without further ado, let's start our class here. And first of all, what we need to do is we need to do a little bit of introduction, and then we are going to talk about Unacademy's subscription and some of the very important things about Unacademy I have to share that I am going to share with you, and then we can start our class. So these things are also very important because you get to know the things which are going to help you. So I have secured All India rank of 662 in GATE 2020. I have completed my MTech in 2019 from IIT BHU Varanasi, and I have got a good teaching experience of 2 years in mechanical engineering subjects. Some of my interests are photo editing, video editing. I like cricket, football and all sorts of games. So I will be taking this entire class in English, and also this class will, and all my classes, just like I took the classes of manufacturing in thermodynamics classes, also I will be sharing some very important information such as tips, tricks, some important things that you have to look when you are doing a question so that you are not going to make some silly mistakes. So all these things will make this class that you are going to take today very worth it, and I recommend again and again to watch these classes live so that you are interacting with me in a way that I think will be the most beneficial for you. So let's start the class with the introduction of Unacademy subscription and Unacademy's website and what they offers. So first of all, you need to go to unacademy.com and follow me there. So I am just waiting for you. Just go to this link and follow me on the website. So when you follow me on the website, what you will find that you are getting all the schedule that I am will be following to take classes on the Unacademy's website, and I will be taking some very exclusive classes there, like you can see thermodynamics. I have taken thermodynamics classes in which we have done important questions only on the website. So if you think that your revision is very fine, if you are just here for the questions, then go to the unacademy.com and just watch the class, attend the class and just learn from the questions that I am going to take there. And there I am taking the most important questions. So you will find that the questions there that I am taking are very much going to make your concepts better. And I just recommend everybody, even if you are reading thermodynamics, study thermodynamics for a first time, to attend those classes. So just visit this link and visit my profile to watch those classes, and also all the notes that are there in my class, all the presentations, PPTs, the slides are available to download for free when you go to my profile and watch my class, or just click on my class. And to download that notes free and to watch the classes for free, because I am taking free classes, free special classes right now on the website of Unacademy, you need to enter this code ABHIMI. This will make you access those free classes and notes on the Unacademy app and website. And also this app is going to give you 10% off when you are going to purchase an Unacademy subscription. You will be getting this discount, exclusive discount. So this code is very important and it has a lot of things, like for example, if you are visiting Unacademy's website and if you are seeing a competition like Unacademy Combat, so that competition requires a code, and this is the code that you can use in all those purposes. So this is a multi-purpose code, and also this code is universal. So not only for GATE exam you will be getting the discount or the free access, you will be getting this discount and free access to all these classes and notes for any subject by using this code only. So I recommend you to just note it down and use it, and download the Unacademy app if you haven't already. The app is very good, and believe me when I'm telling that this app is a lot more advanced and innovative than the competition, because here not only you are getting the traditional type of test and traditional type of classes, you will be getting something very innovative like quizzes, live quizzes, competition, which are designed by keeping in mind that you can even if you want to teach not if you even if you want to just study for little time, the questions are designed in such a way that you can do that also. So if you want to do 5 questions or 10 questions in between of your heavy theory sections, you can just log on to your profile or just download this app and open this app and just give that test series and just move on with the you were doing. So this app is very proper and you have to download it and explore it to see what features it offers and what features you can just take benefit of. So the other thing that I am going to tell is, right now only less than 2 months are left for your GATE examination mechanical. It is 14th of February. So in the Unacademy's app and website, there are a lot of revision classes and crash courses going on. So those revision classes and crash courses will, so this revision classes and crash courses, they are very much important for you to attend, because right now what you want to revise all the formula and you need to give test. So revision and test series both are there in the Unacademy subscription, and some batches are going to start from today only, December 21st 2020. So mechanical batches are starting from the 28th of December. So just go and join there so that you can attend those revision classes. And the best possible way to study in this time, in this last few months, is that do this revision classes, attend this revision classes and give test series. Attend revision classes, do revision and give test series, and learn from your mistake, become familiar with the whole format of GATE and do this thing to get the most advantage. And again I am pointing it out, you have to start attending this class as soon as possible, and they are starting from today, the special batches. And again I am pointing this out, mechanical is starting from 28th of December. By it now, just prepare your schedule according to it, and in this few last days or weeks that is left, follow this way of doing revisions and doing tests, and you will find that you are prepared in a very better way. Because if you are doing this, then you will be finding that you are making use of your time in this last months in a very effective way. Because if you are just studying theory and studying the things which are not important, then you are not utilizing your time at the highest possible manner, which you should totally, because this is the most important time for GATE preparation, and you have to start attending this revision classes, doing revision and just starting the test series. So I hope I have talked about it, and I hope you understand it properly. Now some other things that you will be getting when you subscribe to Unacademy are daily live classes. So you will be getting this live classes daily, where you can ask your doubts, answer polls all while the class is going on. So this polls and this classes, overall the interface of Unacademy, the way the Unacademy live classes are held and way you can interact in this live classes are very better than what is there on YouTube. Because on YouTube the site is not designed specifically keeping in mind for educational purposes, but Unacademy is designed specifically for education, and therefore they are providing these tools which is making a lot of difference when you are attending classes live and using tools and learning through them. So I recommend you to just check out the free classes on Unacademy. Again, visit my profile, attend some exclusive classes there, use the code that I have provided at the start of the class, and I will be providing this code throughout this class by writing it at the top of the screen for you to just use it. So live test and quizzes are also there, structured courses are there, and unlimited essays are there. So if you are subscribing to an academy, you are not only getting the free live classes and the live classes, live courses, but you will also be getting recorded sessions and the test series and quizzes. So overall, and also some quiz competition also. So overall, you are getting a lot of things. So this unlimited access is only available if you subscribe to Unacademy, and only one subscription is needed to get all this subscription benefits. So these are the subscription price for Unacademy. 10% off code ABHIMI. This code will give you this 10% extra discount over the discount already offered by Unacademy in some of the plans here. And no cost EMI is available on 6 months and above subscription plans. And the best plan to choose are from the 12 months, 18 months and 24 months, because they are offering a lot of discount, and this is the final least possible price in which you can get an Unacademy subscription for. And if you are using this code, then the prices you can see here are very reasonable. Just compare them with any competition, any other institution. You will find that the quality, the quantity and the richness of the quality, the amount of things that Unacademy is giving you is far better than anybody he present today. And Unacademy is giving you all of this in a very reasonable cost. And if you are investing time, then you should totally prepare from the best. You should totally use all these resources if you have the budget, and prepare in such a manner that at the end of your whole preparation you are satisfied and you are giving GATE examination with full confidence. And Unacademy will make sure that you are preparing in a better way by properly guiding you. And there is another subscription, Iconic, which is for those who need personal coaches, personalized test series, and overall more assistance if you require. Then this is one of the plan that you should just check out and subscribe. And again, you can use the same code to get 10% extra discount here, and the prices are very reasonable again for the amount of thing or for the type of thing that it is offering. So these are the benefits of Plus and Iconic, and you can subscribe to Unacademy as your need and as your budget, and do it as soon as possible, because not much time is left. And I would recommend you to subscribe to a plan which is more than 1 month, because you will need that for PARC exam and ISRO exams and MTech interviews, company PSU interviews, and all these things. You will be keeping in touch. You can use these resources, and Unacademy is very the Unacademy site is very relaxed. There you will find that you are preparing in a very calm manner, and I think whole Unacademy infrastructure and the website is designed in such a way that you are not going to find it very tiresome while attending the classes there. You are going to find it very relaxing, calm, and overall your whole preparation will go on smoothly if you subscribe to Unacademy. And you should totally check out their website and use this code to attend the free classes, download free notes, and overall get and taste, and then subscribe for the budget you have and for according to your needs. So that's it for Unacademy subscription discussion. Now let's start our class for the day. So before starting this class, before doing some questions, let me provide you with some information about the ideal gas that I didn't provide in my previous class. So first of all, these are some basic things, but again, you should remember all of these things. So let me just start it. So I hope so apologies for that. Actually my pen tablet was reversed, so therefore I had this problem. So let's start that. So I hope now we are good to go. So for ideal gas, the characteristic gas constant, what it is universal gas constant divided by molecular weight. And what is the unit of molecular weight? This is very important. You have to remember this. This is gram per mole, or you can also remember it as kilograms per kilomole. So this is the unit of this molecular weight, and if we divide, and this molecular weight are different for different gases. For air it is 29, for different gas it will be different value, for ethane it will be different, and all these things. So R is, what is the value of R? Again, you should have remember this, you should remember this thing, but I am just writing it down for those who are not able to, since this is a revision class, so I am making sure that you are revising, looking into all of these things again. So this is kilojoule per kg kilomole. So just look into the units here. It is very important. If you are writing above kilojoule, then the below will be kilomole for 8.314 value, and if the value is to be kept same, that is 8.314, then the unit can also be written as this, or joule per kg mole. So this is another way of writing this if you are using this 8.314 value. So other thing about ideal gas is PV is proportional to T. Why? Because for ideal gases PV is equal to N R bar T or M R T. Again, R bar is your universal gas constant, R is your characteristic gas constant. So for adiabatic process you have this equation. So what process have this equation? Adiabatic process. And what is adiabatic process? Adiabatic process is a process where you are having no heat transfer. So adiabatic process is a process where P into V raised to power gamma is C, that is constant. And what is gamma? Gamma is Cp by Cv, the ratio of specific heat at constant pressure and constant value volume, is the ratio of this is gamma, and for air it is 1.4. So if your gas is following this, then this is the adiabatic process. And for adiabatic process, if you just use the formula PV raised to power gamma is equal to C, you can get for a process 1 2. So for a process 1 2 adiabatic process, you will get T2 by T1 you will get T2 by T1 is equal to P2 by P1, but it is having a power which is gamma minus 1 divided by gamma. So this is the relation that is for adiabatic process, and you will find that this relation is having a lot of use in your thermodynamics subject. So just remember this. And for this same process, if we have a relation between T and V, then it will be instead of 2 by 1 we will have v1 by v2, and it will be raised to the power gamma minus 1. So these two relations are very important for your GATE examination, and we will do some questions in which these relations are coming, these relations are having use. But right now you have to remember that these relations are for adiabatic process, and what these relations are, just write it down in your copy if you are not yet remembered it. But if you are remembered it, then it is good. Just check out what you remember is right or not, and matching with this what is written in the screen or not. So let's do our first question of the day. And again, in the revision classes we are going to do some GATE question and some questions that I am finding or that I am thinking that are important for your whole revision series. So the first question will be, so I should first of all add a slide here. So let me add a slide here so that we can do this question. And this question is very important because of the concepts involved here, and I will show you a trick also to do this question in a fast way. So let us do that. So this figure will be coming in use. So what is given in the question is, we are having air contained in a frictionless piston cylinder arrangement as shown in the figure that is on the right side. Atmospheric pressure is 100 kilopascal and the initial pressure of air in the cylinder is 105 kilopascal. Area of the piston is 300 centimeters square, and heat is now added and the piston moves slowly from its initial position until it reaches the stop. So the stops are shown in the figure for you to check out, and the spring constant of the linear spring is 12.5 Newton per mm. So remember, it is Newton per mm. And considering the air inside the cylinder as the system, the work interaction is, so you have to find what is the work interaction if the process that is said in the question is going to occur. And if you are watching this session live, then you can do this question and write down the answer in the comment section or in the chat for me to check out and discuss with you if the answer is right or wrong. So let's write down the important points here, important data that will be required to do this question. So this is a frictionless piston cylinder arrangement. So let me just write it here that the piston is a frictionless piston. So frictionless piston, and atmospheric pressure is 100 kilopascal. So P infinity is 100 kilopascal. It will be very important here. And we have initial pressure of 105. So P1 is 105, and what is the unit? It is kilopascal. Area of the piston is 300 centimeter square. So this is having area, this piston is having area as 300 centimeter square. Heat is added and the piston moves slowly from its initial position until it reaches the stop. So heat is here added, it is shown in the figure already. And spring constant is 12.5 Newton per mm. So that is also going to be coming in use here. Considering air inside the system, air inside the cylinder as system, we have to find the work interaction. And how much piston is going to move is also shown here. 8 centimeter plus 8 centimeter, it will going to move 16 centimeter before coming to stop. So we have to find the work interaction. To find work interaction, let's do this, draw this PV diagram. So let me just draw it with a different color here. So initially we have 105 kilopascal pressure and the ambient pressure is less. So you will find that at this pressure only, let's say we have a volume V1 here and initial pressure is P1. So at this initial pressure P1, you will find your process is starting and it will be a constant pressure process till it reaches a volume V2, which will be after it sweeps 8 centimeter. And why this is a constant pressure? Because you are having a frictionless piston and that 105 kilopascal will be enough for the piston to move because the ambient pressure is not that much. And after that, due to the spring here, the pressure will start increasing linearly and you will find at the end of the process, after the piston comes to stop, that is after it sweeps 8 centimeter, when it starts compressing the spring, the pressure 3 will be very greater than the initial pressure due to the spring there. And this area right here, so this area right here is our work interaction that we have to calculate. So the work interaction is nothing but this area that is shown right now on your screens. So this is 1, this is 2, this is 3, and this is the direction in which the process is occurring. So what we have to find? We have to find this, and to find the area, and the area will be our work interaction. How we can find it? So area is the work interaction and it is P1 into V2 minus V1 plus half P2 plus P3 into V3 minus V2. So area of this rectangular sections and this trapezoidal section will give us the work interaction that is required to get in this answer. And we know P1 is given to us, it is 105 kilopascal, and we also know here the V2 minus V1, it is area of the piston into the volume swept during that time, that will be 8 centimeter length swept or distance swept, that will be 8 centimeter, and if we just multiply 300 centimeter square with 8 centimeter, we will be getting the area swept during this process 1 2, that is V2 minus V1. Similarly, V3 minus V2 can also be calculated via that, and we have to just find P3 to get our whole work interaction here. So our main objective right now is to find this P, is to find this P3. So let's do that. So what will be the P3 here, and let me draw this again, or let us not draw that again, let us just So let us erase the things that are not required here and continue our discussion. So it can't be erased, I think. So let's see the figure from this slide and do the question there. So what will be P3 here? P3 will be the pressure P1 or P2. So P3 will occur when this piston will reach this position. So when piston is reached this position, this is your position 1, this is your position 2, and this is your position 3. So when piston reaches this position 2, you will find that it is having this pressure P2, but now the pressure will increase due to this spring. And what will be the increase in pressure? It will be the spring force K into X divided by the area of piston. So we will find the final pressure P3 equal to, and this is for the final pressure. So final pressure P3 will be equal to 105 kilopascal plus K. What is K? It is 12.5 Newton per mm. So it will be 12.5 kilonewton per meter. And what will be X here? X will be 0.08 and area will be 300 centimeter square, means 300 into 10 to the power minus 4 meter square. So if we do all this, we can find the final pressures. And what will be the final pressure here? It will be 12.5 into 0.08 divided by 300 divided by 10 to the power minus 4. So we are getting, if by after adding this 105, we are going to get the final pressure as 138.33. So 138.33 kilonewton is final pressure. And after calculating this final pressure, this becomes very easy, this question, because the work interaction will be simply half P, or first we have to calculate that. So work interaction will be P, let's write P1 there, because P2 can be also written because it is same only. So P1 V2 minus V1 plus half P3 plus P2, sum of the parallel sides for area of trapezoid, and V3 minus V2. So P1 is 105. What will be V2 minus V1? It will be area, that is 300, into the length that is swept. So 300 into 0.08, and we have to multiply this 10 to the power minus 4 to convert this into the meter square term. And we have to calculate this work in joule. So let's convert this 105 into 1000 to make it into Pascal, plus 1 by 2 into 138.33 into 1000 to convert it into Pascal. And V3 minus V2 will be similar. So the answer, the work interaction, is coming out as 300 into 0.08 into 10 to the power minus 4 into 1000. This is common, and then we have to only multiply 105 plus 138.33. So it is coming out as equal to so here I have to add the P3 plus P2, but I have already written So it will be, so let me write it properly here. So what will be P3 plus P2? P3 plus P2 will be 105 plus 138.33. You are going to get 243.33. So we have 300 into 0.08 into 1000 into 10 to the power minus 4 into 105 plus 0.5 into 243.33. So the answer is coming out as approximately, it is coming out as 543.996, so approximately 544 joules. So this will be our answer. And as you can see, this question is very easy, but you have to understand some of the things here that is given in the question. And I have explained this question in very detail so that you can solve it properly by yourself and you can understand why we are doing the things that we are doing here. So first of all, let's see what is there to be seen in the question. Air is contained in a frictionless piston cylinder arrangement. So the first term that is important here is frictionless piston cylinder arrangement. So this will inform you that a constant pressure process is there when there is no interference by this spring. So frictionless piston, whenever comes, you can be aware that a constant pressure process is there. Atmospheric pressure is given 1000 kilopascal. We don't have to use that because our initial pressure is greater than that, and that pressure will do the work, and we have to find the work interaction. And area of piston is given as 300 centimeter square, so that is going to be very important to calculate the pressure due to the spring. Heat is added, so when the heat is going to add, there will be a temperature change and there will be the work done. So the work done we have to calculate here, and spring constant is given in Newton per mm, so don't always take the spring constant in Newton per meter. Sometimes other unit is given. This also important, you check the spring constant unit while you are doing a TOME question, theory of machines question, because there sometimes it is given in some other units and mistakes might happen if you are not careful there. So air inside the cylinder is considered as system, and we have to find the work interaction in joule. So what we talked about here is your piston after receiving heat will go from state 1 to state 2, that is from the initial position to the position where it is coming in contact with the spring. So during that it will be having a constant pressure process, and that constant pressure process will have the PV diagram look like as shown in the figure. The 1 2 will be constant pressure process line similar to that, and the area under that will give you the work done during that process, and it is quite simple to calculate that, and we can calculate that very soon. But the other thing here you have to see is, due to this spring, the pressure will keep on increasing as pressure will be proportional to the volume swept or the length swept, and therefore it will have a direct increase in pressure with the more volume or the more spring is getting compressed. Therefore it is having this increasing linear relation, and as it increases it will achieve a pressure 3 when it finally stops at the position due to the stop position, and the pressure reached there is going to be very important in this question, because we have to calculate that pressure to calculate the area under that 2-3 process curve. And when we add this whole area from the process of below the process 2-3 and below the process 1-2, then we will find our work interaction that is required to give in this question. And this is this year's question only, so you can see what type of recent questions are there, and it is not that hard, but you have to remember how this is happening, why this is happening, and I hope I am clear when I am discussing about it. And the other thing here is how to calculate this pressure 3. So pressure 3 will be simply pressure 1 plus the additional pressure that is occurring due to the compressing of this spring. That will be kx, spring force divided by the cross sectional area of the piston, and it can be calculated very easily. But you have to calculate here by keeping in mind that the units of P1, that is the first term, to calculate P3 and kx by A are same. So the pressure finally is coming out 138.33 kilopascal. Then you have to put this in the equation that is shown below, that will calculate the area under the curve 1, 2, 3, and that will give you the final answer, that is 544 joules, which is the work interaction. And there is other way to do this question. Your work will be, simply take the pressure P1 and assume that there is no spring there. So you will find that your V3 minus V2 V1, that is the final, or let me just write it like this so it is better clear to you. Assume that there is no spring first, then your final volume minus initial volume into the pressure, because pressure will not change if there is no spring and it will remain this P1 only, plus the work done to compress the spring by the x units, and x is the distance. So x is the 8 centimeter. You are compressing the spring by 8 centimeter. So if we do this, we will find the same answer, and what it will be, 105. The final volume, it will be 2 into difference between final and initial volume will be 2 into 300 into 10 to the power minus 4 into 0.08 plus half. What is K? It is 12.5 into 1000 Newton per meter, and x square will be 0.08 square. So let's calculate and see if we are getting the same answer or if we are getting something different. So 105 cos 2 cos 300 cross 10 to the power minus 4 cross 0.08, and this we are calculating in kilojoule, because we are writing this first term in pressure in kilopascal. So let's multiply here 1000 so that we are getting the answer in joules in which it is asked. So 504 is due to there being no spring, only this pressure P1, and this much of whole volume is swept, 8 plus 8 16 centimeter. Then we have to find what is the work done to compress that spring. So this is one of the easier ways to do this question, and the answer is coming out exactly like what we discussed. It is 544 joules, and I gave GATE examination this year, and this question was done by me by following this process, this second alternative solution or way to do this question, and I did this question very quickly. So the other way is also very easy, and you can just do this question very easily in if you do this question by this way also, but you have to just have this concept known to you what is happening, and here just know if there is spring and if it is frictionless, then the spring will get compressed. So due to that, the work done total will be, if there is no spring, assume, then calculate the work done due to initial pressure, and then calculate the work done in just compressing the spring to the required length, and then we can find the answer simply. So you have these two options to calculate the answer here. So let us move on and discuss the other questions here. So 1 kg of air initially at a temperature of 127 degrees Celsius expands reversibly at a constant pressure until the volume is doubled. If the gas constant of air is 287 joule per kg Kelvin, the magnitude of work transfer is asked in kilojoule, round off to 2 decimal places. This is also this year's question, and this question is quite easy. So let's do this very quickly. 1 kg of air initially at temperature T1 is 127 degrees Celsius. Mass is 1 kg and it is air. And we have this expanding reversibly at constant pressure. So constant pressure, reversible process. Volume is doubled, so your final volume is 2 times of your initial volume. Gas constant is given 287, and you have to remember this because in some questions this will not be given. This is a standard value, 287 joule per kg Kelvin. So remember this value. Magnitude of work transfer. So we know we have to calculate here the boundary work. So boundary work will be W is equal to integration P dV, and we will find W boundary work as, if pressure is constant, P delta V. So what is pressure? Pressure we have to calculate here, so that we can calculate by using this ideal gas law. PV is equal to mRT. So from here pressure will come out to be, what is M is 1, then we have 287 joule per kg Kelvin, then we have a temperature 127 plus 273 and divided by volume, and the volume is not here, so we will just calculate this in terms of volume. So it will be 114.8 divided by V kilopascals. Why kilopascal? Because we have to find the answer in kilojoule, so I am calculating this in kilopascal. So 114.8 divided by this V, and change in volume will be 2V minus V, and this whole answer will be coming out in kilojoule. So answer is coming out as 114.8 kilojoule. So I hope this answer is clear to you, and this question is quite easy. We worked our way by first writing the data, then seeing what we have to calculate, and it is quite easy question. So I hope you are able to understand this. And again, if you are watching this session live here and you have just joined us, so I am also taking classes on the Unacademy's website, and you can follow me there and use this code to watch free classes on Unacademy app and website. The code is at the top of your screen, ABHIMI, and this code will not only give you free classes of mine, but all the educators that are taking place, you can watch their classes free, and by using this code, and download their notes also. So now let's talk about some of the details or information about the heat phenomena and heat transfer processes. So let me just take out what I have to teach here, because I have written some of the little topics that I have to cover, so that I am covering all the things that to cover here, and then moving forward. So first I am starting this by telling you the definition of heat. So what is definition of heat? We talked about the definition of work, and now we are going to talk about the definition of heat, and this both are energy transfer process, and energy can be changed or transformed via, or mainly energy can be changed via heat transfer, work transfer, or mass transfer. Why mass transfer? Because energy is an extensive property, so it depends upon mass. So if mass is getting changed, energy will get changed. So what is heat? Heat is a method of energy transfer which takes place due to temperature difference. So due to temperature difference, this heat transfer or heat transfer is taking place, and so the main driving factor of heat is temperature difference, delta T. And now let's talk about Cp and Cv, because this was the main important point that I was uh, going to discuss here. So Cp is specific heat at constant pressure and Cv is specific heat at constant volume. What is specific heat? C is your specific heat. So to define specific heat, you have to look no further than its unit. So specific heat is having this unit kilojoule per kg Kelvin, or you can also write it as joule, because we are going to talk about the definition. So joule per kg Kelvin. So this is the unit of specific heat, and from this you can get the definition that how much joules or how much energy you have to require to change 1 kg of an object's temperature by 1 Kelvin or 1 degree Celsius. Also, it is also having this unit. Since we are talking about temperature change, so it doesn't matter if the change in temperature is in degree Celsius or Kelvin, because both will give the same temperature change. And this is the definition of specific heat. And if specific heat is occurring at a process or which is constant pressure, then it will be constant pressure specific heat, and specific heat at constant volume is for constant volume processes. So this is what specific heat is. And now let me give you one very important information about Cp and Cv, which will help you differentiate it even more. So Cp includes both internal energy U and boundary. So Cp is including both internal energy and boundary work, but Cv is only includes U, that is internal energy. So this will differentiate Cp and Cv more, and from this you can tell that Cp is greater than Cv, and this is always the case because Cv is including, or Cv is going to represent this internal energy plus the boundary work, and Cv is only for this internal energy, that is specific heat at constant volume, will be only including that. So you have to just remember this, and from this you can remember that Cp is greater than Cv, and that is also going to give you this information that Cp minus Cv is R, and the R is positive, and you have to remember this also that Cp minus Cv is R, and this will be very helpful in a lot of numericals that you are going to do in GATE exam preparation and GATE exam also. And Cp by Cv will be your the specific heat ratios, and it is gamma, and it is coming in the adiabatic process formula, that is PV raised to power gamma is equal to C. So again you have to remember this very carefully. And now let's talk about how we can use this specific heat constants. So Q is equal to mc delta T or dt. So let's write delta T, and here the C is specific heat, and if we are talking about this mc is heat capacity, and this C is specific heat. And delta T is temperature difference. Since we are talking about heat, so there will be temperature difference, because as I have said, it is main driving factor for heat, and heat transfer will occur only when there is temperature difference. If there is no temperature difference, then there will be no heat transfer occur. So we have QP is equal to mCp delta T, and this will include both the internal energy plus the work done. But QV, specific heat at constant volume, will be here, and this will only account for internal energy. So you can say that QP is equal to, so therefore QP is equal to mCp delta T is equal to mCv delta T plus W, because this is nothing but internal energy. So this is again a very important point that I have talked about, and we have also talked about in the previous slide this gamma, which is the specific heat ratio. And let me inform you here that specific heat ratio values are different for different types of gases. For example, for monoatomic gases, it is having a different volume value. For diatomic gases, it is having different value. And for tri or more, you are going to see different value. Maximum for this 1.67, then 1.4, and minimum for tri or more 1.33. So this is values of gamma, specific heat ratio, which will be very important. Sometimes it may be given in the question, but you have to remember them. And also remember that they are maximum for monoatomic gases. And now let's talk about this in detail. So a little bit more detail by drawing some figures here. So for example, you have this cylinder, and in the cylinder you have this piston. And let's talk about by drawing this same. So we are comparing this Cp and Cv, and what they represent, it should be clear to you after seeing this. And let's provide heat here. And here we are provided stoppers. So this stopper is provided here, and here we are providing QP, because there is no constant volume. So QP will be provided here, and that QP will go on and increase this internal energy and do some work, and that work will be boundary work. But here no work can be done because volume is constant. So the Q which will be provided is QV, and it will be used entirely for the purpose of increasing the internal energy or change in internal energy. This change in internal energy will occur when there is stoppers and when heat is provided, so that entire heat is going to increase the temperature of the system only, not on any energy will be used to do the work, and therefore this heat will be doing this only process, and that is QV, and that QV will be represented by mCv delta T. Excuse me for that. So I hope you have understood the difference between QP and QB and what they are accounting for. So why QP will be always greater than QB for the rest of the parameters same, because CP is greater than CV. Why? Because CP is including both the change in internal energy and the boundary work, and CV is only including the change in internal energy. So I hope this is clear to you. Now we can move and do our question, but before doing that, let me also here inform you about the air properties, which I think you should remember. It is very important because not always these air properties are given. So some of the standard air properties you have to remember, such as Cp will be equal to 1.005 kilojoule. It is kilojoule, not joule, per kg Kelvin or degrees Celsius. Then Cp, it will be having the value 0.718. Units are going to be same. R is going to be Cp minus Cv. It will be it will be 0.287, and it was also given in one of the questions that I did or that we discussed here. So it is 0.287. Units are same, so I'm not going to write it down again. Remember, these are in kilojoules. Then we have a capital M molecular weight. It is 29 gram per mole, or you can also write it as kilogram per kilomole. Both will have the same 29 value. So that is it. And gamma, Cp by Cv, if you take, it will be 1.4. So this is specific heat ratio. So I hope you are able to understand why these are important and able to write this and learn this, because these are very important and you should totally remember this in detail. So now let's talk about this, some questions that we have left for the day. So we have this 1 question, 2 question, 3, 4 and 5. So 5 questions are left for us to discuss today, and we will discuss them, and this will involve heat and work. That are the topics that we have already have our discussion about. So we will do this question very quickly and then we will end this class. So it is given that Cp is equal to this much, and the change in enthalpy we have to calculate. And what is enthalpy? So what is change in enthalpy? So change in enthalpy is dH. Since the Cp is given in this specific terms, that is species given in not specific terms, this divided by kg, and there is no mass given in the question, so we will calculate specific enthalpy, which will be Cp dt. So to calculate change in enthalpy, we are just going to integrate this from 1 and 2, this dH. So it will become H2 minus H1, which will become delta H, and it will be equal to integration of Cp dt. And what is Cp? From the question, it is 0.88 plus 2.6 into 10 to the power minus 4 T, and the units are given, and then we will have this dt, and this will be integrated from 1 to 2, and T1 and T2 value are given in the question. But the most important thing for you to remember here, or just look here, notice here, is that the T is given in Kelvin, or is to be put in Kelvin in the equation that is given for Cp. So if you are putting T there in degree Celsius, then you will get wrong answer, because it is stated that T is in Kelvin, so that is the unit in which you have to put it. So T is in Kelvin, so put it in that only. Do not put T in any other unit, degree Celsius, to get the wrong answer. So we will just simply do this integration and find our delta H, which we are asked to calculate, and we have to calculate this delta H in the units kilojoule per kg. I think it is not written here, so this is the unit we have to find this answer in. So it will be 0.88 T plus 1.3 into 10 to the power minus 4 T square, and the units will be T1, T2. So T1 is given 30 degree Celsius, T2 is given 150 degrees Celsius, but we have to write those down in Kelvin. So I am just going to write 0.88 into the temperature, which is T2. So T2 is 150 plus 273. So it will be coming out as 423. So 423 Kelvin plus 1.3 into 10 to the power minus 4 into 423 square minus 0.88 into 303. 30 degrees Celsius is 303 Kelvin plus 1.3 into 10 to the power minus 4 into 303 square. So by doing this calculation, we can find our answer here, which will come out as 0.88 into 423 plus 1.3 into 10 to the power minus 4 plus 4 into 423 square minus 0.88 into 303 minus 1.3 into 10 to the power minus 4 into 303 square. So we are getting answer approximately as 117 kilojoule per kg. So this is the answer, and this question is quite good because you are getting to know this type of question. I don't think that it is yet asked in the GATE examination. So I think a very good question, because always GATE try to ask something different. At least you will find that 20 to 30% questions will be different, which is not there in the GATE examination, but it will be there from your syllabus. And this question just is very good because here, see, in GATE examination, teachers usually give you the questions where you are doing some silly mistakes or common mistakes which you are going to do if you are not properly reading the question or not properly applying the basic logics. So in this question, there is mistake in using this temperature degree Celsius in the equation instead of Kelvin, and hence getting the wrong answer. So this will be very careful. This you have to be very careful when doing questions like this. So the only thing that you can do here is you can read the question properly so that you are very well aware of what units is to be put to get the right answer and what unit is the question is asking the answer in. And I hope this question is clear to you. Again, you can attend classes live. The next classes of thermodynamics will be common mistakes, where we will discuss all these things that we have talked about in a single class, and I will take that common mistake class again after completing some 4 or 5 thermodynamics classes, and we will discuss some new mistakes that you have to be very aware of to not make from the thermodynamics section. And after that we will talk about and do revision of the first law of thermodynamics, then second law of thermodynamics, then there will be Carnot and Clausius inequality there, then we will talk about entropy, available energy, then pure substance, and our thermodynamic sessions will be ending there. A frictionless piston cylinder device and a rigid tank contains, each of them has this 2 kilomole of an ideal gas at same temperature, pressure and volume. The final temperature of both the system is raised by 15 degrees Celsius by transferring heat to them. The amount of extra heat supplied to the gas in the cylinder that is maintained at a constant pressure is. The amount of extra heat we have to calculate that is supplied to the gas in the cylinder, and the first thing you have to notice is frictionless piston cylinder device is given. So this means that there will be a constant pressure process occurring here. So this pistonless will give you this information, and it is written in the question also that supplied to the gas in the cylinder that is maintained at constant pressure. And that constant pressure, you can before reading this line, you can guess that by the frictionless piston cylinder device information that is given. And to do this question, let's write what is given first. So it is given the N is 2 kilomoles and we have same temperature, pressure and volume The temperature of both the system is raised by, so delta T is 15 degree Celsius, and this is going to be very much important information, that one of the cylinder is constant pressure and other is rigid, and we have discussed a lot of concept about this constant pressure and constant volume heat transfer. So we have to calculate how much extra heat is transferred to the gas in the cylinder that is maintained at constant pressure as compared to the gas which is there at constant volume due to the tank being rigid. So delta Q will be M Cp delta T minus M Cv delta T, and this will be nothing but M Cp minus Cv delta T. So this question I am doing very fastly, very easy question. Again you can see, so we have this Mr delta T, but here we don't know what gas it is. It can be air, it can be some other gas, because it is not specifically stated. So we cannot use R as 0.287 and we cannot use M because it is not given, but we are provided with this N, and we know that M into R is equal to N into R bar, where R bar is your universal gas constant and delta T will be the same that is given, and universal gas constant is always given as the 8.314 kilojoule per kg kilomole, and the N is 2 kilomole. So we are going to get this answer in kilojoule is the unit we have to find this answer in. So it will be Nr, and N is 2. So 2 into 8.314 into 15, we are going to get our answer as 249.42 kilojoule. So even if our mass is not given, we have calculated the heat in kilojoules because we have used N into R bar, which is the universal gas constant, into delta T to get our answer. And this answer is going to give you this detail that this extra heat that is supplied to the cylinder that is at constant pressure will go in what? It will go to do the boundary work, because the rest of the heat that is there is getting used for the internal energy increase, and so 249.42, which is the amount of extra heat supplied to the cylinder, which is maintained at constant pressure, is there for this work done. So I hope this question you can see and you can understand what are the things that is important to learn here. I have talked about it, and you can also here just see that it is very easy question, but you have to remember some little bit of things like Cp minus Cv is R and your Mr is equal to N R bar. So a good question here. So let's do our final two questions of the day. So it is going to be needing a diagram, this question, and that diagram I have this with me. So let me just draw that. But before drawing that diagram, let us first draw that diagram. I am drawing that diagram, then we will talk about what is written in the question. So volume is given in meter cube and pressure is given in bar. And you have this 4 bar and this 1 bar here in the y-axis and 1 meter cube given in the x-axis. So the process is going in this direction, you can see, and first second, third, these are the states. And here, so here all the information I have provided that is going to be required to do this question. So a system undergoes three quasi-static processes sequentially as indicated in the figure. So in the sequence, that is first 1 2 is happening, that is a isobaric process. From the figure itself and from the name isobaric, you can say it is a constant pressure process. And the next process is process 2 3, which is a polytropic process with the n equal to, so I have drawn it wrongly, I think it will be little bit curved because of the polytropic process. It is a polytropic process with n equal to 0.4 there, and let us write it here. Here we have this process, and the other process is a PV is equal to C process, which is nothing but a constant temperature process, that is isothermal process. So our first volume V1 is given as 1 meter cube, and P1 and P2 is given as 4 bars, and P3 is given as 1 bar. The question that is asking in the first part here is volume of the system at the state point 2 in meter cube. So we have to calculate here V2 volume in meter cube. So let's see what is the volume at 2, and we have this data, and we know V1 only, and PV is equal to C, and we know P1 and P2. So since for process 1 3 PV is equal to constant, so P1 V1 is equal to P3 V3. This we can say, but we have to calculate V2, and let's say if we can calculate V3, then only we can calculate V2. So from here P1 will be 4 bar and P3 will be 1 bar. So 4 into 1 is equal to 1 into V3. So V3 is coming out to be 4 meter cube. And other formula, so for process 2 3 we have PV raised to the power 1.4 is equal to constant, so P2 V 1.42 is equal to P3 V3 raised to power 1.4. So P2 and P3 we know, so it will be 4 into V2, which we have to calculate, raised to the power 1.4 into 1 into 4 raised to the power 1.4. So our answer, that is the volume of 2, is going to come out as, what will be the volume of 2 here? So it will be 4 divided by 4 raised to power 1.4, sorry, 1.4 raised to power 1.4 divided by 4 raised to the power 1 divided by 1.4. So it will come out as 1.486 meter cube. So answer that is given here, that is matching our calculation, is D, 1.486 meter cube. That is volume of 2 in this process here. So you cannot calculate volume directly by using the values of state 1 and then state 2, because P is equal to C, and we have to know about this other volume by the process V3 first, by the process 1 3, then from the process 2 3 we can calculate V2. So the last question of the day is, net heat interaction for the cycle in kilojoule is. So what is the net heat interaction for the cycle here in kilojoule? So we have this whole process, and here process 2-3 is adiabatic because PV raised to power gamma is equal to C, and therefore heat there will be 0. Then we have this isothermal process and constant pressure process. For isothermal process, we have to calculate the heat there, and the heat will be, for isothermal process there will be no internal energy change, so the heat will simply be the work that is done on that process. And in the process 1-2 we have constant pressure, so we can calculate heat there. Let's see, heat interaction in the cycle is to be calculated. So what we can do here is we can either draw this in TS diagram and then calculate the area there, that will give us the heat, or what we can do, we can calculate heat in the individual process and then find it. But other thing that is that the whole, that in a cycle the, what I can say here is that in a cycle Q net is equal to work net. So simply we will calculate work net, that will be equal to Q net, because the cycle is having this value, because from the first law of thermodynamics, which we will study in the next class, you will see that in a cycle the change in internal energy is 0, because internal energy is a property. So here we just have to calculate the work done. So work done for the process 1, 2, 2, 3 and 3, 1 is to be calculated, and let's calculate them, add them, and then we will get the final answer here. So for process 1, 2 we will have constant pressure. So constant pressure is 400 kilopascal into change in volume. So what is the volume here? Volume 2 is 1.486, so it will be V2 minus V1. Then we will have the work done for that adiabatic process or polytropic process, P1 V1 minus P2 V2 with n is equal to 1.4, so it will be 1.4 minus 1, and we know the values of all this, and this will be P2 V2 minus P3 V3 since process 2 and 3 is going on. Then we have the constant temperature process, so it will be P1 V1 ln V1 divided by V3. So let's calculate this. So the first term is coming out as 1.486 minus 1 into 400, so it is coming out as 194.4. Since the volume is increasing, so the gas is expanding, so therefore the work done is positive. Then we have P2 V2. So what is P2? P2 is your 400. What is V2? V2 is your 1.486 minus P3 100 into 4 divided by 0.4. We will get 48 point, or not 48.486 there. Then we have to calculate this P1 V1. So P1 V1 will be 400 into 1 into ln. What is V1? It is 1. V3 is 4. So it is coming out as minus 554.51 or 52. So this will be the value here, and net work done will be now coming as 125.88, which is nearly equal to 126 kilojoule. So this will be the answer that is correct here, A 126 kilojoule. So I hope you are understanding why we have done this net work done calculation, because by first law of thermodynamics the first law of thermodynamics is nothing but del Q is equal to du plus del W. So if you integrate, you will find Q is equal to delta U plus W, and this in a cycle, if you are doing this integration, then you will find that Q net is equal to W net, because in the cycle delta U will be 0 because change in energy will be 0 if we are going from point 1 and then coming back to point 1, then the net change will be 0 for a property like internal energy. So therefore the correct answer will be 126 kilojoule. So that's it for today's class, and if you want, then you can follow me on unacademy.com. Here is the channel's my profiles link. You can just write it down in your copy and then enter in the browser, and then you will be taken to my profile. There I am taking a lot of free classes, lot of free notes you can download from the classes there, and you can use the code ABHIMI to download the free notes and to watch the free classes, and follow me so that whenever I go live, you can watch my classes live. You can get my proper schedule so that you can see when in which day I am taking which classes, and this is the code which you can use to watch free classes on Unacademy app and website, ABHIMI in all capital letters. You can just use this code in any class to watch any class, to watch any download any notes for any exam. This code is valid. This is universal code, and today only you should subscribe to Unacademy and start your preparation by watching revision classes. A lot of new classes are going on, like I have shown here in one of the slides here. The two batches are starting here for GATE 2022 and GATE 23, and you should totally start this batches also and start the revision classes also, which are going on at the same time on the Unacademy's website. So these classes and batches will start on the date that is given on the in the slide here, and you should start from the day one so that you are very well aware of the topics, and you can learn in a manner which is intended, not learn from middle, so that you can understand everything properly. So that's it for today's class. If you found this class helpful, then hit the like button, subscribe to this channel, and hit the bell icon for notifications. So whenever an educator goes live, you can watch his or her class live, and live class are far better than classes which are recorded and archived, because there you can interact in a very better way. And use this code to join Unacademy at 10% off, and join it as soon as possible for GATE 2021, because a lot of crash courses and revision classes are going on. And again, I'm telling you, this is the time that where you have to only attend the revision classes and do test series and revise, and also look into the past previous year GATE papers. And all this thing, if you do, you will find that you are very well prepared for your GATE examination, and you are very confident about your preparation. So overall, you will have your chance of scoring GATE score better if you are following these things. So that's it for today's class. Thank you for watching. Stay safe, take care, and best of luck for your preparation. That's it for today's class.